Hello. In this video, we're going to take a look at the area of rectangles program from your textbook. So we're going to begin by taking a good look at the problem. It says the area of a rectangle is the rectangle's length times its width. Write a program that asks for the length and the width of two rectangles. The program should tell the user which rectangle has the greater area, or if the areas are the same. So we're going to set up some pseudocode to approach this. And of course, we learned in chapter 2 that pseudocode is the logic of the program. So we want to set that up for this problem. So we want to think about what we need to do. And chapter 2 helps us understand that we need to break our programs down into three basic sections: an input section, a processing section where the multiplications will occur, and then an output section where we'll be printing our answers to the screen. Okay, so if we thought about this for a little while, we probably would come up with something similar to what we have right here, which is we first must ask the user to put in the length and the width of the first rectangle. And then we would ask the user to input the length and the width of the second rectangle. And then we would calculate the area of the first rectangle. Then we would calculate the area of the second rectangle. So that's the input section and most of the processing section. Now, some of the processing we've got down here in the output section. So once we have assigned the area to a variable such as the area 1 for the first rectangle and area 2 for the second rectangle, then we can use some Boolean expressions here, and we can compare them and find out which execution path the program needs to take. Does it need to take the display that rectangle 1 has the greatest area or the greater area? Does rectangle 2 have the greater area, or do they both have the same area? So what we want to do here is think about how we would code this, and using some of the logic that we found in chapter 3 of your textbook. Okay, so let's talk about setting this up now in Python. So the first thing that I would probably do is write a comment statement. So I'm going to get the dimensions of rectangle 1 from the user. And I'm going to do that by setting up a variable called length1. And it's going to be set to get the input, enter the length of rectangle 1. And I'm going to have to convert that from a string literal, which is what input function returns. So I've put the entire input function inside the int function. Therefore, length1 will hold an integer after this line executes. And width1 is similar. We can load the contents of what the user types in to the input function and then convert it to an integer and store that in width1. Okay, and then we would have two similar statements for dimensions of the second rectangle. The only difference here is that the variables end in 2, and we just ask the user to enter the information for the second rectangle. So those two are very similar. Then we would want to do some calculations. So I've typed a comment statement right here: calculate the area of the rectangles. And of course, area 1 will be equal to the length of 1 times the width of 1, and area 2 will be equal to the length of 2 times the width of 2. So we can get that area by multiplying these two numbers together. Length 1 times width 1 will equal area 1. And area 2 will be equal to length 2 times width 2. And then we need to take a look at how we might get our logic here now. So if we go back to this, we need to set up a 3-case scenario. The first case would be that rectangle 1 has the greater area. The second case would be rectangle 2 has the greater area. And the third case would be both rectangles have the same area. So that's what we want to set up now. So as we work through this, we can determine which has the greater area. So if area 1 is greater than area 2, then print rectangle 1 has the greater area. I think in my pseudocode I had greatest, but greater is better here. Okay, so if the area 1 is larger than area 2, then this will print, and the program will terminate at that point. The other statements below that are going to be put on the screen in a few minutes will not execute. If the program goes into here, it won't see the rest of the code in this program. Okay, so now, but if that wasn't true, then we're going to have an else situation. Now, if we remember from the screen we were looking at in our pseudocode, in English we called it else if. But in Python syntax, Python has a syntax, and the syntax is that we use a substitution for else if, and we use elif. So right here, elif. It's a combination of else and if. Okay, so that's what is commonly used in Python. All right, so if that's the case, then we will print the rectangle 2 has the greater area. Now, if this is not true, and if this is not true, then something else must happen. But before we take a look at that, let's look at this. We're using greater than here in both cases, but that's because we switched area 2 to be first before area 1, right? So just catch on here to what we did here. We kept this point in the same direction because we switched our variables here. Okay, so just be aware of that. All right, so if neither one of those two cases is true, then else, then what must be true is both have the same area. All right, so that's pretty much how we could do this problem in one manner. So let's run this and see how it works. We got basically 3 cases to test. So let's run this, and let's have 10 and 20 for the dimensions of the first rectangle. And let's have 100 and 200. And rectangle 2 is larger, has a greater area. Now let's run it again. And let's check out the opposite case. Let's put in 100 and 200 for the first rectangle, and then put in 10 and 20 for the second rectangle. And you can see here that rectangle 1 has the greater area, whereas the first time rectangle 2 had the greater area. Now, if we run it again, and this time we try to make sure they have the exact same area, 10 and 20 and 10 and 20, then they both have the same area. Okay? So that is one way we could do this problem, which is this is actually the preferred way. This is the way that I prefer that you would do the problem right here. Use the elif. We'll talk more about that as we progress through the semester, but the elif is the preferred way, and we're going to talk about that just a little bit. But let's take a look at another way that we could do this problem, and but it's basically the same logic. So let's start out, and a lot of the first part of this program is going to be identical. So we're going to get length 1 just like we did in the other program. We're going to get width 1 just like we did in the other program, and so on. And even down through here, it's the same. But when we get down here, it's different. So we want to talk about handling this decision structure just a little bit differently. And it will give you an idea of how you sometimes need to nest if statements within each other. So let's see how this might look. So we would start off the same as before. If area 1 is greater than area 2, then we would print rectangle 1 has the greater area. But now if we did this a little different, we would not use an elif, we would use an else here. And then we would nest the next if statement inside the else part of the first if statement. And it's very important here, the spacing. This is 4 spaces. this, and so if you don't space this correctly, you're going to get some type of error. So let's go ahead and see. So if area 1 is greater than area 2, then rectangle 1 has a greater area. But if area 2 is greater than area 1, rectangle 2 has the greater area. But if neither one of those is true, this time we would have an else. So see, instead of having an elif here, we've got two else, which is a little harder to keep up with, and you've got a lot more indentation going on. You've got 4 spaces and you've got 4 more, and that can get kind of tricky. So that's another reason that I'm going to encourage students to use the elif structure in Python. All right, so but anyway, if neither one of these two ifs have been triggered, then we would have the else, which would catch the rest of them coming down in here, and both have the same area. So now we want to run this with similar data like we ran before and see if we get the same. We should get the exact same outcome. So if we start off up here like we did earlier with 10 and 20 and then 100 and 200. So let's do 10 and 20 and then 100 and then 200. Rectangle 2 has a greater area, and that's what we got earlier. Okay, and let's run it again. And this time we're going to put in 100 and then 200 and then 10 and then 20. And rectangle 1 has a greater area, just like we did before. And the last test case would be to make them the same. So let's run that again. And we used 10 and 20 and 10 and 20. So we'll use that here as well. So 10, 20, 10, 20, and both have the same area. So that's two ways to do the program, both of which have the same logic. So take a minute here and see if I can get both of these on the screen at the same time. I may be able to, may not. I've got quite a few windows open here. So there's one way. That's the first way we did it. Okay. And let's see if I can get this one up here now. And that's the second way we did it. So I'll just slide this over just a little bit right here. And there you go. You can see this is the preferred way here, highlighting it on the left there. And on the right over here is another way to do the same program, or what we say in the programming world is this is the same logic as this, but I think most people believe this, and I do. I think this is less confusing to use the elif than this. Okay, so that concludes the areas of rectangles problem for chapter 3.